let me just start this up. I left this desktop purposely on the screen because some of you may remember that I was introduced to this community in San Francisco when I presented a project named after my grandfather. So this slate is, the project was bunsyswirl.org. It generates dynamic math worksheets for elementary schools using a tech and TICSET backend. So this is his, the house is still standing. He is, of course, long since passed, but this is a little bit of brickwork in front of his house, and I was just there a few weeks ago. So, Fluss, flow monitoring system. First off, before I get into my presentation, I wanted to tell you all how delighted I am to be back in Germany after 22 years. I was here in late November 1993, and I have very, very vivid memories, some of which I have shared with you over meals. In 1993, my wife and I were driving a little 60 horsepower Fiat Tipo from Munich through southern Germany, and almost constantly the song that we heard was one from Four Non Blancs, and I went hunting for the CD. What's Going On was the song. So this time, 22 years later, I'm coming to Germany. My son has fallen in love with a German band called Milky Chance from Kassel, and I'm on the hunt for a t-shirt and a CD for him, even though Milky Chance is coming to Toronto this Thursday, and he is going to be attending their concert on the beach in Toronto. So, Will already mentioned that he is shocked to see Germany being green, or perhaps just any place being green given the season in Australia. I also have another vivid memory of that trip to Germany. We visited Garmisch-Partenkirchen, and all I remember was the fog. There was no green, there was no blue, there was no red. So, Will, yes, I'm glad that I can see green, but I'm more glad that I can see yellow, purple, pink, and every other color under the spectrum. What is Fluss? Oops. So, Fluss it's an acronym. I do my best to do something local. So Fluss is, the working title stood for Flow Leaks Unearthed Using a 2 Sigma Testing. Now, those of you, and I do not profess to be a statistician, those days are long, long gone. It's a convenient classification metric where the normal distribution within 1 standard deviation is approximately 68%, 2 standard deviations is 95%, 3 standard deviations is 97.5%. So if you want to classify a sample as being inside the class or outside the class, a convenience test is a 2 sigma test. So if it's outside 2 standard deviations, maybe it's an outlier. But as you will find out as this presentation goes along, the 2 sigma test, we don't actually know whether it hasn't been verified. So for the purpose, for right now, we'll just call it some sigma testing. I don't know exactly how many sigmas we will be testing. In Boston, I presented what started off being a 3-year initiative on specification-driven documentation. It began with a rather innocuous presentation about a workflow which took from the MVC framework and used YAML to create models, Ruby for the controller code, and used tech to do the view. And over the 2 subsequent TUG conferences, I enhanced it and I went a little bit further. But I'm asking up front your indulgence that there may not be sufficient typesetting content for this audience. So why am I here? Well, there is an ancillary question that I'm sure needs to be answered as well. So what does this have to do with typesetting? Very little. But what does it have to do with tech? Does it even have anything to do with tech? And I hope to convince you that it has a great deal to do with tech. And how do we resolve this paradox? So I think everyone has come across this term that's very much in vogue now called IoT, the Internet of Things. Well, I'm offering a possible solution to Hans's dilemma. And I put the there because it's definitive. We'll now call it from here on in the Hans dilemma, which he articulated so beautifully yesterday. I am advocating that we look at the tech of things. And we promote this concept because, and maybe I'll get back to it in the conclusions, but I think the question has been perhaps it perhaps can be framed a little bit differently. We keep asking ourselves, how many users use tech? And that's not the right question. The question is, how many users use the output of tech, however that may be produced? And I would like to offer up this presentation as just dipping a toe in the ocean as another possible path to expand the use of users of tech's output, which is, I think, the far more critical metric. And in order to do so, we need to start considering tech not only as a standalone system, not only as Hans with his high-powered laptop generating 40,000 documents an hour, but consider tech as part of a core of an embedded system, tech-enabled devices. And why I am advocating considering this approach is there are a whole class of problems which do require a sophisticated documentation backend. It may not be a publishing domain requirement, but it's certainly an essential requirement. So when we're immersed in tech and when we're at these TUG conferences, we're looking for projects like we want to look at the sun. We want to be blinded by the brilliance, and it should be the 3 sigma rule, 99.7% tech, or maybe it's not qualifying. No, I don't think that's an appropriate way to look at it. If we walk in the garden behind us, we want to hear the birds, we want to smell the flowers, and yes, the sun is illuminating the path in front of us. I want us to consider tech to be the light that's illuminating the path in front of us, but not to the exclusion of our other senses. So, back to the subject at hand. How do we use the tech of things to detect water leaks? In North America, of course, the percentage of people that are in standalone homes is quite high. And building codes require, like here, smoke detectors and other detection devices, and that's how you prevent or you catch fires at an early stage. So you don't wait for you don't have a fire detector, you have a smoke detector. And there is no equivalent regulation for water. Increasingly, insurance companies are suffering huge claims due to water damage. This is actually one of our projects. We left the site with paper on the ground on a Friday evening about 7 p.m. And the following day I got a frantic call from the client that we have Niagara Falls in our main foyer. Fortunately, it wasn't anything we had done. It was a drain had burst in the roof. So we cannot prevent leaks from happening, but we can limit the extent of the damage. And how this project, I've been working on this project for about a year. This project came about because insurance companies are becoming much more stringent on requiring some form of leak detection, quote unquote. I say this in quotes because I purposely say flow metering, as a prerequisite to getting house insurance. They simply will not give you house insurance at a certain point or a certain class of home unless you can convince them that you have put something into place that would be an early warning for a leak, a water leak. So what are the sources of leaks? There's the water supply that comes into the house and throughout the house. There are the drains and stack, and of course, we have these wonderful European slide and tilt windows, which are rare in North America and that allow great ventilation. I'm only concerned about the water supply. So that is some sort of breakage or leak
tap being left on, a pipe burst, etc., at the water supply. And I want to make a distinction very clearly between leak detection and flow monitoring. As you can see from, well, I hope you can see from, oops, sorry. I've gone too far ahead. There we are. Impressive. I keep forgetting what the keystrokes are for impressive. The entire ceiling has been breached. There's water coming down. And if you were to go a leak detection approach, I cannot imagine what sensor you would require to, and purposely place it at that one location in order to catch the leak. By this time, you can imagine what's happening above the ceiling. There's water across the whole span. And so you can see here, I'm not sure about construction here, but this is a drywall ceiling, and the entire drywall seams are about to give way. These chandeliers, by the way, are full of water already. Okay. How does flow monitoring detect leaks? Well, the idea is that rather than catching leaks at the terminals, we want to monitor the flow at the source. There's usually a water main coming into a house, and I'm sure in apartments and flats there's a similar sort of notion. There's a water meter inside the house, right here. This is a particularly grand house, let's put it that way. We know that water consumption will vary by time of day, shower time, meal time. It'll vary between weekdays and weekends, and it'll vary seasonally if lawn irrigation is on, unless you're in California, supposedly, allegedly. So the idea was to learn water consumption patterns as time went on, and going back to the sum sigma test, if a sample comes in and it's outside of a 2 or 3 or 5 sigma, the black swan event, then there would be a potential water, and you would communicate that, alert that. There's an extended application by going the metering route rather than the detection route, is that you can handle different types of fluid. Homes in North America, especially homes with hydronic heating, which is quite common in Europe, have both a water circuit and a glycol circuit for areas where there's a danger of freezing. We can calibrate to different pipe materials, so whether it's copper or PEX, like plastic pipes, common again in Europe. Ability to handle different pipe diameters, wall thicknesses of the pipe itself. Copper comes in different standards, and having multiple sensors. So I'll go through this quickly. I just want to give you a sense of the problem domain, so you I hope can appreciate how dire the consequences can be when a water leak happens. So in this house, those 2 boilers are just for the garage. There are 7 boilers in this house. The tank on the right-hand side is the glycol overflow circuit. And in this house, typical in Canada at least, the main water main is 3/4 of an inch. Here you have 1 1/4 inches, which I get 3 centimeters. Pipe dimensions still are in inches there. And it's a type L pipe, which means it's meant for heating. Or it's a thicker wall pipe, I should say. It's also used for heating. Why should we focus in on the monitoring? Well, it goes back to whether we want to intervene. The simple solutions that are out there in the marketplace, the ad hoc, you go into a big box home building supply, they might offer this up. What it is, it's a very simple, either mechanical, electromechanical device with a valve, and it'll shut off the water to the house if it thinks that there is excessive flow. There's a huge, huge danger with that approach. And that's why I differentiated between a curated intervention and an unattended intervention. We want software upgrades to happen unattended. We do not want flow to be shut off to a house in an unattended fashion. And the reason is this. This is 1/4 of the hydronic circuit for this house. And if we were to cut off the water to the house, the heating would stop or get starved. And if the heating stops, the house freezes and maybe more pipes burst. We definitely do not want it to be unattended. So now let's talk about the tech of things. And I hope I haven't, I know this may sound very esoteric, and I probably lost 90% of the crowd when I said it has nothing to do with typesetting. But I hope to convince you that there's still value in this. What's the platform architecture when we're talking about embedded systems and the possibility of using tech on embedded systems? Well, the most common architecture, I'll talk about the Jakobson use case diagram or sequence diagram first to give you an idea of what I had designed as far as the flow between the actors and the messages. So we have a sensor and a meter. It was in the earlier photographs. RS485 is a variant of RS232, the serial ports that we all have on our computers, or we did at one point. I still remember logging into my first PDP with a silent 700 Ti with thermal paper to run user games at Bell Labs, where my uncle worked. We have a collector actor, which samples something from the meter and sensor. Why I say something? Because you don't have an accumulator in these meters. You essentially are given a digitized version of the analog current that the meter is picking up, and you calibrate it for the pipe conductivity and what type of fluid is going through the pipe. The meter comes from food processing. There is no meter or sensor large enough to clamp onto an 1 1/4 pipe. I used the Python dataset modular package, and all that does is it abstracts the database layer, and just we talk in very generic terms about tables and samples. The data store takes that sample and stores it. The processor takes the sample and turns it into a data point. Now, what do I mean by that? A sample, you have to have a sample frequency because, as I mentioned, there's no accumulator in the meter. So let's say you decide you want 60 samples an hour, 6 samples an hour. We'll get into some of the combinatorial issues. But then we need to be able to handle it back into time series. That matrix or the table I put up earlier showed that we're trying to capture usage patterns by time of day, day of week. So that's the data acquisition part of the project. The data analysis, we have a classifier agent which takes the samples and the data points from the data store and starts to analyze them, create models about the probability distributions. And if there is something untoward, then it alerts the user, the property manager, whomever you want. And there's 2 aspects to it. One, there's a web SMS service called Twilio. Have any of you come across this? So it has a RESTful interface. You can program it in a variety of languages, but essentially it turns it into a URI, and it can send an SMS anywhere in the world. The second part is I wanted to use context to generate reports. Essentially using context to create a dashboard that would be meaningful and then either can spit out reports ad hoc or on demand. And the mechanism to do that was through SMTP. So the platform itself for an embedded system. Very cheap and cheery, a Raspberry Pi Model 1 B+. Why? Because Debian is available, and of course cost. It's should be relatively impervious to harsh environments. We can put it in a mechanical room without too much worry, and if should it fail, it's easy enough to replace. The software requirements. I mentioned context. I wanted to have Python 3.4. I wanted to have the dataset library, SciPy, NumPy, and matplotlib, which is this marvelous package by the late John Hunter. Out of all these, which do you think, there's only one, that worked out of the box? Yes, TechLive was the true unattended installation. You could start it up, and I think, Boris, you and I correspond. I think you're responsible for some of the ARM HF binaries, so thank you. And the TechLive packaging is a marvel. And along with C10, I think we're very privileged to have all of the effort in the back end. Everything else was an absolutely torturous effort. Some months ago, I wish I had a picture. I looked like Robert Plant. Do you know Robert Plant, Led Zeppelin, right? I had hair like this. At the end of this is what I look like. Okay, what were the platform challenges? Raspbian is based on Debian Wheezy. And so you have Python 3.2, not 3.4, which means that all the downstream packages break. Or you stay with 2.7, but you don't get some of the functionality. Failed installations, yes, there were all sorts of inconsistent packaging. Python 2.2 is not UTF-8 compliant. Some of the downstream packages are. The next item, it's a 3-word sentence fragment, inadequate swap space. I cannot tell you how many days I agonized. I thought I would have to abandon the Raspberry Pi platform. There's almost no information on the net on this issue. But Raspberry Pi, out of necessity, it runs off a micro SD card, has only 100 megs of swap space. And if you try to compile or bring down anything through the pip system, it will fail, but it will not tell you why it's failed. It'll just say, I don't know, I'm giving up. And quite literally, it took me several days to stumble across one oblique, obscure reference that, well, if you get strange errors, maybe you want to increase the swap space. Platform performance. I want to go back to Hans's comments that hardware has improved to a point where we might not need to optimize the code as much. So this is, piplog is my own log, and this is the result of, in a virtual end, Python, are there Python users here? I'm new to Python, so pip install SciPy. And if you do the delta subtraction, if you have your HP calculators, which I hope you all have in RPN, you will see that that took 8.5 hours. And 8.5 hours on a successful run. Never mind all the aborted attempts before that. So we are looking at definite platform challenges in terms of performance, and if we're going to put the tech of things into practice, we do need to be acutely aware of performance optimization. The data challenges now. Now we're into the nuts of where tech comes into play, if not so much the typesetting part. Flow is non-zero by definition. It's coming into the house. It's not going back into the grid the way electricity can sometimes work. So what type of probability distribution function do we use? My hope was we use a simple normal distribution, and you can either do a shift, a translation, and it'll make a zero mean, maybe something 100, and then shift it back and all that. But there are 3 other candidates: gamma, log normal, folded normal. So I played around with those. Combinatorial scale. If we want a very simple time series with 50 data points, we will need an enormous number of samples, 500,000 samples, and a year of time to put that data together before you can do any analysis. So there are very much some data challenges to here. Now, again, I ask your indulgence. So obviously, we don't have a year of actual data. We need seed data to get things rolling and then to interject new samples from the meter. So I played with the distributions. I talked to the client about nominal consumption, so what hours would you have your showers and this like that. And I essentially came up with some guesstimates, some means. I'm using the Fluss philosophy, release early and release often. Let's try it out. Let's see what's going on. So I'm just going to go over to and I hope you can see this. So this is a context-generated report that through SMTP I can receive on my phone. It is by day of the week and by hour of the day. What I ended up settling on was a folded normal distribution. So there's a bit of sleight of hand here. After playing with the distributions, I decided on folded normal distribution, and I generated sample data assuming a folded normal distribution. If we zoom right in, and perhaps it's not that clear, but at midnight, water consumption, the node is around 0 or 0.25 gallons per hour. But if we go to a full page, you will see that around 6 a.m. we have nominal water consumption between Monday and Friday, and maybe a bit later on Sunday and Saturday. And as we progress through the day and reach peak dinner time, the water consumption increases. So we have the histogram of samples, and we have a fitted curve using or assuming a folded normal distribution. Now we have enough to do the testing, and when a new sample comes in, to decide whether some sigma, using a some sigma test, if it's outside of a couple of, we don't have the notion of standard deviation in folded normal, but if a new sample comes in and it shows excessive flow, then perhaps there's a water leak imminent or underway. Is that making sense? I'm seeing more perplexed faces. So here you've got 12 to 2300. It's a 2-page report, and this is from 0 to 11. It's all right? Now let's look at a leak version of the same report. Can anyone tell me where the leak is happening?
Yeah, what was that?
So, without getting into the minutiae of the data analysis, and by the way, Joaquin, you said that naive users simply post on Tech Exchange, right? Me as a naive user, I'm posting on Tug Exchange. You're here. This is not a finished project. I am here to solicit opinions. I'm not a statistician. As I mentioned, my statistical pattern recognition was decades old. I'm looking for ideas. I'm looking for suggestions to incorporate into this workflow. So at a glance, you can tell that a water leak has happened between 2 and potential water leak, because in this case, unless you were getting an SMS at 3 in the morning and you're looking at it 3 days later, well, obviously the water leak has stopped, or it was an unusual consumption pattern during those 3 hours. This is quite common. When pools are opened in North America, they have a separate circuit, and they just run a hose and run it for 36 hours straight to fill the pool. So it might have been that this is a summer pool opening, but at least it gives you at a glance an idea that something untoward is happening in the house. Are there any thoughts about the reports?
What are the axes of each of the
Very good. So yes, I do have if you just bear with me, I'll just switch directories and I will show you. Let's see if that works. Matplotlib has this wonderful subplot function which allows you to do independent axes. So the histogram is just the number of samples. It's nominally flow per hour, but remember, this is simulated data. This could be anything, flow per minute, doesn't matter. All I've done is I've generated random variables using SciPy's folded normal distribution. And then I have fitted that generated data back into its curve fitting model. The right side is just the PDF, not the typesetting PDF, it's the probability distribution function. So as you get closer to 0, the folded normal distribution becomes this hump. But if you, let's see here, let's take something 4.7. Oh, that wasn't very good. Let's see here. So you can see, as it goes away from 0, it's still biased to the left because it's a folded normal distribution, but as you go away from 0, because there's no negative flow, it takes on the semblance of a a regular normal, a standard normal distribution. Sorry, Boris, you had another question?
The question, how long do you need, how much training do you need for your system to get the distribution? How long does it need to gather?
Again, I'm struggling with the data because in order to get 50 data points for each type, there's 160, if you look at the matrix, 168 cells in the table. So by hour of the day of the week, assume each of those cells, we only can get 50 data points to create that. It's not enough, but it's something. FOSS, right?
Yeah. So
that's a year's worth of data. That's 500,000 samples that we need to take.
Yeah.
So I can run it with 1 million samples, 2 years worth of data. So, just backfill it. But what we need is, it's like a seed for a random number generator. We're using a seed for a classification system. We're saying, okay, hey, house user, normally when do you have your showers in the morning? Well, we have them at between 5 in the morning and 7 in the morning. And so we'll guess. We'll say the seed flow is 25 gallons per minute. Yes? Yeah, this is going to be interactive. Sorry, Boris, just one second. Yes?
Do you quote about some, not statistical, but pattern detection? For example, if flow is still in the long time, is probably something wrong. And if flow don't have a valley in the night, this is something. If flow rapidly goes up and then is
a step function. Yes, it's an excellent point. Those are all good candidates for heuristics that we can use. Absolutely.
And the second thought I have, what about some sound detection on the pipe? If there is flow from the leak, from the breaking of pipe, it has another sound that from the valve.
That's also possible. Now, the only issue is
some other kind of sensors.
Yes. When the pipe is so far away from the meter and it's embedded in the wall, the system has to be retrofit into an existing house. It's not always with new construction.
But the water is good transmitter of sound.
You're right. Yeah. So you're saying that
contact microphone in the inlet, you can sound all the installation.
Yes, if I understand correctly, you're saying the water will go from laminar flow to turbulent flow because of the.
Yes, all right.
Right. Okay. That's a great idea. Yes.
I think
Harold. Sorry.
Sorry. There are similar projects which are called smart metering for both electric power usage in houses, and they also sometimes collect data for water flow, water usage, and gas usage. You can get a lot of data if you look around for smart metering projects for real data, even for water usage. So it might be possible to really get real data.
Yes.
Talking with them, and also getting an idea, because that's not only about just metering electric users, but they're all about figuring out how the usage concept is, which devices for electrical usage they are. So they're really getting time scales and see to figure out which device is running. Is the device running in proper way, or did you leave your what is this? Heat iron on when you're heading to the airport, things like that. The same is true also for water usage, of course. And a comment for the metering concept. What I know from smart metering projects, at least in Germany, they typically really tap the main water clock or water meter. A lot of them are able either to give direct electric pulses or signals, or you can enhance them with a electric contact, and you get resolutions down to 1 to 10 liters per information. So
The challenge in this sort of situation is you cannot break the main into the house. You cannot work upstream from the meter. And so one of the things I didn't mention was the way that the sensor, this coming from the food processing industry, the sensor that we've installed is ultrasonic. It clamps on, and then you calibrate it for. Are we running out of time? Sorry. I'll just quickly mention conclusions, and then we can come back to this over a break. I'm sorry it's taken a bit of a long time. So, going back to the Hans dilemma, which I think, Hans, we should copyright. The tech of things can offer up solutions to a new class of problems. I hope I've convinced you of that if we look beyond publishing or document creation, and we start thinking of tech as part of the toolbox. When you use Bash or awk or sed or whatever you decide to use, when you log into a Unix system, you just expect it to be there, and you use it as you need it. It doesn't mean that every project in the world has to be written in awk. We shouldn't assume the target hardware platforms, because if we're going after embedded systems, we will need performance optimizations with tech and other. And maybe we can start marketing powered by tech. If I can just steal 30 more seconds, I have one quick epilogue. I think all of you have seen me carrying this very archaic camera around, and after each conference, I offer up the link to the specific conference with the photographs with some commentary. But I thought, and I've suggested this to Carl, and he said, well, it's hard to do through TUG directly, but I'll offer this up to anyone who's interested. There are 5 conferences shown on this URL. Endeavorhouse.org is my personal server, and tug.chronicles is there. Please be mindful, like in context, it's mixed case start conference, and just to make it a little bit more difficult, it's a double /. And you can grab me for the details, and please try it out. Is there time for questions or no? We're really beyond.
We probably need to, we'll take one question.
Okay.
Sorry, Boris, there was a question earlier.
Actually, I have 2 questions or remarks. First, why don't you use a real-time series analysis, like in statistical analysis? So you have a year base or month base, and you have a daily base, and then you can do with the data parameter estimation, and then get the incorrect behavior.
So you're talking more like a polynomial fit rather than a class.
Not polynomials, but with symbols into scales and some random pair.
Okay.
So, and the second question: how do you decide? So in statistics, we have type 1 and type 2 errors, or what is?
This is all ad hoc. This is, at this point, we're not even there yet. Okay. What we're trying to do is build that framework and the whole architecture, and then we'll start testing. So, good point.
Okay.
Okay, thank you so much.